All right, problem 3-102. Istasha wants to learn more about excluded values. Explain to Istasha why x cannot be 4 in the expression the quantity of x plus 2 divided by the quantity of x minus 4. So we've got our expression copied down here. Let's just take a look at what happens when x is 4. So if we plug in 4 for our x, we're going to have 4 plus 2 over 4 minus 4. 4 plus 2 is going to give us 6. 4 minus 4 is going to give us 0. And we know that we can never end up with 0 in our denominator because it gives us an undefined value. So if we wanted to write out an answer for this problem, we could say x cannot equal 4 because our denominator ends up equaling 0. So x cannot equal 4 because our denominator then equals 0. This would make our value undefined, or we could say the value of this expression is then undefined. So x cannot equal 4. Okay, that's what we call a restriction, because x cannot equal 4, so it's a restricted value. Now B says find the excluded values of x in each of the expressions of problem 3-99. So I guess I should point out there, it's called an excluded value or restriction. There's different terminology for it there, but that means the same thing. So excluded value and restrictions would mean the same thing. So you may hear it different ways depending on whose class you're in. So in this one, we want to find the excluded values from this problem 3-99, which was part of your in-class work. So we need to look at our denominators, and we need to figure out what values of x would make our denominators equal 0. The easiest way to do that, we take our denominator, and we have 3x plus 1. If we want to know what value of x is going to make this equal 0, we can take it and set it equal to 0. Then we go ahead and we solve it there for x. So I'd subtract my 1. I have 3x equals negative 1 divided by my 3 on each side, and I get x equals negative 1/3. So I know if x equals negative 1/3, it's going to make the denominator of this fraction equal 0. So I can say then that x cannot equal negative 1/3. And let's look at, we have another expression over here, and this was the quantity of x minus 5 also times the quantity of 3x plus 1. Well, since there are two factors in this one, we know if either of them equals 0, then it's going to make the entire denominator equal 0. And since 3x plus 1, this expression is repeated in the first one, we don't need to solve that one again. We've already done that. We know that x cannot equal negative 1/3 for this particular factor. For this one, same thing. Just say x minus 5 equals 0 to figure out what x value would make it equal 0, and that obviously there would be 5. So x cannot equal negative 1/3, and x cannot equal 5. For problem B in 399, we had the expression 9 minus 3x over the quantity of x plus 3 times the quantity of x minus 3. And then we were adding 2x over the quantity of x plus 3. So once again, we have a repeated factor in our denominator. So there's no sense in solving it twice to figure out what that value would be. We only need to do that once, and then we also need to worry about our other value. So if we look at x plus 3, what would make that equal 0? And what would make x minus 3 equal 0? Well, those ones are nice and easy. We should get x equals -3, and we get x equals +3, which means if that is what is going to make our denominator equal 0, we know that those are going to be our excluded values. So x cannot equal -3, and x cannot equal +3. And tell you what, the easier thing will be, let's just say x cannot equal positive or -3. Now the last question here, and we'll go up and read it and then we'll scroll back down, says create an expression that has the excluded values of x cannot equal -6 and x cannot equal 1/3. Be prepared to share your expression to the class. So your answers for this one could vary. We just need to make sure that the excluded values are coming from the denominator. If you look at what you just did in part B, we ended with x equals, or x cannot equal 5. Think about where that came from in this problem. If we go up, we say let x equal 5, and then find a way to set it equal to 0. It's kind of working backwards to come up with an expression. Let's do the same thing with our x cannot equal -6. So let's say x cannot equal -6. So we need to find an expression where -6 would make our expression equal 0. So let's just go ahead and change it to x equals -6. And to get an expression here, let's set it equal to 0. Let's add 6 to each side. And we get x plus 6 equals 0. Okay, which means here, if we have some sort of fraction here, and our denominator is x plus 6, we know our excluded value would be -6. If we took our -6 and we plugged it in for x, that would end up giving us 0 in our denominator. So as long as we have x plus 6 in our denominator for part of our overall expression, that'll work. And it doesn't even matter what we have in the top. We could just say 1 over the quantity of x plus 6. And I'm just going to make my other excluded value come from a separate fraction. I could say plus, and now let's do the same thing with x cannot equal 1/3. So x cannot equal 1/3, which means we need to come up with a value for x that equals 1/3. So x equals 1/3. Well, there's different approaches you could take. You could subtract 1/3 from each side. I don't like leaving fractions in there, so what I'm going to do here is I'm going to go ahead and I'm going to change my equation by multiplying both sides times a 3 first. And that's going to give me 3x equals 3 times 1/3 is going to be 1. Now to set it equal to 0, I'm going to go ahead and just subtract 1 from each side. And I'm going to end up with 3x minus 1 equals 0. So for me, that would be an expression that I could have in my denominator that would have an excluded value of 1/3. So I'm going to put, and you can put whatever you want in the top. You could have another expression with x in it. You could have just a numeral. In this case, just because it's easy, I'm going to go ahead and put just 1 on this one as well. The main thing is that you have the quantity of x plus 6 in one of your denominators and the quantity of 3x minus 1 in one of your denominators. Once again, these are excluded values. You also hear them called restricted values, possibly in class as well. If you have questions, please make sure you ask your teacher. Hope this helps.